Okay, any of these we have to go over. Did we get them all right? No questions on those? No? Okay, well, we're going to go ahead and start the unit. Start the official notes. So let's go back and let's look at our notes. So we're going to do 1.6a. 1.6a. Now, you've seen some of these types of equations, and in fact, you had some little surprises in your homework at the end of the semester last year, the last homework assignment. Originally, we had this first semester, but with the new block scheduling, we lost a little bit of time, so we wanted to formally bump it to this semester, but not ignore it because it's important. So let's go ahead and talk about how we're going to solve other types of equations involving polynomials and radical expressions, those little square root, cube root, etc. So if you recall, if you want to solve, I can't write on here, hang on. Solve an equation, what we are really trying to do is find all of the values of the variable that cause the equation to be true. So in other words, we have an equation, we see an equal sign, and we're trying to solve for the value of those variables, of the variable. Right now it'll be one variable. And in other words, once we get the value of the variable, if I substitute it back into the original equation or any equivalent form of that equation, if I get a true statement, then I've solved for the value of the variable. Now, most often when we are trying to do that, we try to isolate the variable. In other words, we move things away from the variable so that we can identify what x equals or what z equals. If you remember those wonderful little equations that have a bunch of variables and you had to solve for them last semester. So let's say you're given this equation. The first thing you might want to determine is what is the degree of this equation. So I'm looking for my highest exponent of the variable. So we would say the degree of this equation is what? Is 3. So that is going to imply that I have 3 solutions to this equation. In other words, x could equal potentially 3 different unique values, distinct values. Now, we'll see that perhaps we don't have 3 different values of x. We may have only one and it's repeated 3 times, or we may have 2 and one of them is repeated. And we'll talk about the multiplicity of the solutions. But right now, I know technically, since this is a cubic equation, the highest degree is 3, that I potentially can have up to 3 unique solutions. So the first thing I would do is I would rewrite the equation, bringing all my terms to one side of the equation and set it equal to 0. So that means I'm moving the 4x and I'm moving the 4 and I'm doing the opposite operation. So I'm subtracting each of those from both sides. Okay, so then that would give me x cubed plus x squared minus 4x minus 4 equals 0. So all I've done is rewritten the equation and set it equal to 0. Now, hopefully when you see this 4-term cubic polynomial on the left-hand side, that your gut instinct would be to factor by grouping. So maybe, maybe not, but in this case, I'm looking at these 4 terms and I want to factor by grouping. Now, that means I'm going to look at the first 2 terms and then the second 2 terms, and I'm going to try to find the greatest common factor from each of those sets. So if I look at the first 2, what would the greatest common factor be for that? X squared. So if I factor out an x squared, what's left over when I divide each of those terms by x squared? X plus 1. Okay, now I'm going to look at the next 2 terms and I'm going to say, what is the greatest common factor that I can factor out of each of those two terms, but keeping in mind that I want to maybe have an x plus 1 if possible inside the parentheses. So, a negative 4. So if I factor a negative 4 out, what am I left with? X plus 1. Now, you may want to clean that up a little bit and combine that plus a minus, making that negative 4x plus 1. And then at that point, I would factor out that x plus 1 from each of these. And what would be left over when I took x plus 1 and divided out of each of those? What would I be left with? X squared minus 4. Now, at this point, are we done? No, we can keep factoring because what's happening inside those brackets, inside the parentheses? It's the difference of two squares. So I can keep going. I would have x plus 1 on the outside, but then I would take this one step further and I would factor this x squared minus 4 as to what two binomials? X plus 2 and x minus 2. Now, does it matter whether I put the x plus 2 or the x minus 2 first? No, order doesn't matter. What property tells me that's true? Commutative property of multiplication, right? So it doesn't matter. Now, the zero product property at this point tells me I can set each of those factors equal to 0. So I can set the x plus 1 equals to 0, x plus 2 equals to 0, and x minus 2 equal to 0. The zero product property tells me I can do that. Then I'm going to solve for x in each one. So go ahead and solve for x. I'm going to get x equal negative 1. Solve for x in the next equation. I'm going to get x equals negative 2. Solve for x in the next equation, and I get x equal 2. Now, we do want to get in the habit of checking our solutions. Algebraically, we arrived at these three values of x. But as the problems get more interesting, there's going to be some values of x that we have to exclude, which would make potentially one or more of these values of x extraneous solutions, meaning they don't work when I substitute back into the original equation. So you do want to get in the habit of checking. So you want to go back to the original equation and substitute in each of those values of x to make sure you get an identity. Go ahead and do that and tell me, are each of these true solutions, valid solutions, or are any of them extraneous that we have to omit from the solution set? Check them. Do they work? They each work. So you could write the solution as x equal negative 1, x equal negative 2, x equal 2, or you can write x equal negative 1, negative 2, 2, or you can write it as a solution set, but then remember for sets, we write them in ascending order and never repeat a value. So I don't care, unless I say represented as a set, I don't care how you give it to me, Cooper.
When we go back to plug those in,
Substitute.
Do we go back to the equation in the question or when it equals 0, or does that?
It doesn't matter because they're equivalent, right? They're equivalent. By just moving terms to the other side of the equation, it doesn't matter. I don't care. Okay. Best practice, we kind of always want to make sure, because as the problems get a little bit more interesting, maybe you're doing something to get an equivalent equation. This one, it doesn't matter. Okay, moving on. Here we go. They're gonna just get better and better and better. All right, now here I have an equation, and it has a radical symbol in it. So I see on the left-hand side, I have the square root of 20 minus 8x equals x. Now, when you have an equation that has a radical symbol in it, you may have one, you may have two, you may have more. If possible, try to isolate one of the radical expressions on one side of the equation. Why? Because I can easily do something to each side at this point to get rid of the radical expression, the radical sign. I can address this because what could I possibly do to each side so that I no longer have that square root? I can square both sides. So if I square each side, if I square the left-hand side, what do I have? Left. 20 minus 8x, right? Because that's technically 20 minus 8x to the 1/2 power to the, then to squared, and then power to a power, you multiply, which makes the exponent 1, which just gives us the 20 minus 8x. And then on the right-hand side, I have x squared. Now, I'm trying to solve for x. In my heart of hearts, I know I should have potentially how many solutions? 2, because the degree is 2. But this is written in a form that maybe I want to do something to this equation to make it easier to find those 2 values of x. What would you like to do? Okay, you can subtract. You want to get everything to one side of the equation and set it equal to 0. It doesn't matter whether I move the x squared to the left by subtracting or whether I move the 20 and the minus 8x to the right-hand side by doing the opposite operations. We're just moving everything to one side of the equation. The 2 sides of the equation are balanced, so it doesn't matter what we move. I personally like to have the leading coefficient to be positive. So even if I did move the x squared to the left by subtracting, I'd want to divide everything by -1. To avoid having to do all those steps and mess with negative numbers, I personally am going to subtract 20. But do you see how it doesn't matter? Okay. All right, so this is going to give me x squared, and I'm going to put it in exponentially descending order, meaning my powers of x start with 2 and then 1 and then 0. And again, since the 2 sides are balanced, I can just put my non-zero terms on the left and set it equal to 0. Now, this is a quadratic trinomial. What can we do to that? You can split the middle term, or you can guess and check. Exactly, but we're factoring. We're factoring. We're factoring. So, method of choice, factor, tell me what my 2 roots are. What are my 2 factors? Give me the entire factor, the binomial. And x minus 2. And again, that commutative property multiplication says it doesn't matter which one I write first. Zero product property says set each of those little factors equal to 0 and solve for x. So I get x equal -10 and x equal 2. Check those solutions in the original equation. And here we do want to, like, address the fact that, we have to be careful with the radical. So maybe go back to this one, this 4. Check those and tell me, do we have any extraneous solutions? Algebraically, we got these 2 values, but I'm not so convinced that they are both valid. They are? -10 is extraneous. So I'm going to be looking to see that you algebraically found those values, both of them in this case. But then I am also looking to see that you checked it and realized that x equal -10 is extraneous. I'm sorry?
What is extraneous?
Extra. It doesn't count. It's not valid. It's not an actual solution. Algebraically, we arrived at that value, but when substituted back into the original equation, it is not true. Okay? So I need to see you mark it and write extraneous. So I know you found it, but it's not an actual solution. What about x equal 2? It's valid. So my solution set is just 2. Again, I'm looking that you algebraically found all values of x, but then that you recognize if any of them are extraneous. And these will become more and more and more important when we're dealing with certain types of functions and perhaps domain restrictions on the function. All right, moving on. Oh, what do we want to do first? Exactly. Isolate the radical expression by doing what? Add 6 to both sides. Beautiful. So that's going to give me the square root of 2x plus 15 equals, I can either write 6 plus x or x plus 6. Again, the commutative property of addition says it doesn't matter. I like to have my variable first because that just makes me comfortable. So that's what I did. But it doesn't matter. You're going to get the same answer no matter what. Now, I've isolated that radical expression on the left-hand side. What am I doing to solve for x? I am squaring both sides. Squaring the left-hand side just brings that radicand outside of the radical symbol. But on the right-hand side, I have a binomial squared. How do we address the binomial squared? FOIL. Yeah, just FOIL. Just FOIL. So on the left, I have 2x plus 15. On the right, first terms multiplied together give me first x squared, outer, inner, and last. Combine like terms on the right-hand side. Now, I'm solving for potentially how many values of x? 2 unique values of x. So how am I going to do that? That's right. Move all your non-zero terms to one side of the equation, setting it equal to 0. Again, it doesn't matter. I'm going to go ahead and do this because I just like to keep my x squared positive. It makes me happy. But then I'm going to put those on the left-hand side of the equation so I can set it equal to 0. So I'm going to get x squared what? Then factor that. Tell me what the 2 factors are. Beautiful. Zero product property tells me I can set each of those little factors, each of those little binomials equal to 0. Solve for x. And I get x equal -7 and x equal -3. Are they both valid, or are either or both of those extraneous? Check it and tell me. Do we agree? If I substitute in -7, are you sure? What did you get when you substituted into the radicand? What does the radicand become? 1 minus 6 is -5. -5 doesn't equal -7. -7 is an extraneous solution. So while this one is valid, I have the solution set just being x equal -3. Can we get that? Right? Do you see it?
Yes.
Okay. These just keep getting better and better. Let's look at the next one. Oh my. I have 2 radical expressions on the left-hand side. Oh, but I have a 1 on the right-hand side. Yeah, but I would be foiling the left-hand side. Okay, so you're telling me to subtract this square root of 3x plus 7, right? From each side. Okay, I can do that. I would do that. Giving me square root of x plus 2 equals 1 minus the square root of 3x plus 7. And again, I could put negative square root of 3x plus 7 plus 1, but, you know, to me, this looks prettier. It's more aesthetically appealing to me. And now you would do what? You want to square both sides. So I'm squaring the left-hand side, and I'm squaring the binomial on the right-hand side. So the left-hand side becomes just x plus 2, but on the right-hand side, I am foiling the product of those two binomials. So if I multiply my first terms together, I get 1. If I multiply my outer terms together, minus the square root of 3x plus 7, yes? If I multiply my inner terms together, minus the square root of 3x plus 7. If I multiply my last terms together, what do I get? Plus 3x plus 7. You with me? Are y'all all with me? Do you see how we foiled that? Farah, yes? Cece? Yes? Lucy? This makes sense? Dylan? You know, impressed? You know, everybody getting this? That's important, right? Do you see that? Okay, now I'm going to combine my like terms on the right-hand side of the equation. So I'm going to combine these two. So I have x plus 2 equals 1. And if I combine those two, what do I get? I have one of them, a negative, and then another negative. So that gives me, yes. Okay, I'm not worried yet. What would you do next? Okay, if I combine the 7 and the 1, what do I have? 8. And then what do I do with that? Yes, I want to isolate this. So I technically need to move this, this to the left. I need to move this to the left. I need to move this to the left side of the equation. Does that make sense? I want to isolate that radical expression. So I'm moving everything else to the other side of the equation and combining like terms. So I have x minus 3x, which gives me negative 2x, and then I have 2. And this is really ugly here, but sorry. I have plus 7, right? Minus 1. That's really ugly. That's a little better. So 2 minus 7 minus 1 gives me, well, 2 minus 7 is negative 5. Negative 5 and negative 1 is negative 6. That's all right. It's all right. It's not the end of the world yet. Now what? What do you want to do? There's not just technically one thing we could do, but what would make this problem easier? I kind of would, yeah. I kind of would. And the reason I would do that is because each of those terms on the left-hand side of the equation are even, so they're divisible by 2. Why not? So what do I now have on the left-hand side of the equation? X plus 3, indeed. And on the right-hand side, I have isolated that radical expression. So now what?
We square it.
Square both sides. That is a binomial squared on the left-hand side. And then the radicand comes out of the radical symbol. So if I FOIL the left-hand side, what do I have? Now this is an easy problem, right? What do we do? Move everything to one side of the equation, setting it equal to 0. So by doing that, What do I now have on the left-hand side of the equation?
X squared plus 3x plus 2.
Beautiful. And you can factor that. That's a nice little quadratic trinomial you can factor. What are my two factors? So that means I have x equal -2 and x equal -1 is my potential solutions. Algebraically, I found those two values of x, but am I done? No, you better check those answers. You go back to that original problem. And you check those answers. Check x equal -2, check x equal -1. You tell me, are either of those extraneous?
Isn't there a problem with the square root of 0?
Is there a problem with the square root of 0?
Or is it just 0?
As long as you're not raising 0 to the 0 power, which we have to address a little bit later in math, you're okay. So that's okay.
-1.
X equal -1. Austin is saying it's extraneous. Do we agree with Austin?
Yes.
Well, of course we do. In this case, we do. So my solution set is just x equal -2. -2 is the solution to this, right? And again, you can give it to me as x equal or in the set, I don't care. Now, just when we thought we couldn't have any more fun, we get this. Oh, look at that beautiful problem. You tell me how we would begin this problem.
Add 1 and then add x. The square root of x.
Yes, I'm trying my best to get a one radical, even if it has a radical inside, on either side. Okay, so I have the square root of 1 plus 4 times the square root of x, that's fine, equals 1 plus the square root of x. All right, now what? Yeah, square each side. Let's see what happens. Okay, so the left-hand side just becomes 1 plus 4 times. We're just getting rid of those radicals left and right. But I am foiling the right-hand side because that's a binomial times a binomial. So the left-hand side is 1 plus 4 times the square root of x. If I FOIL the right-hand side, what do I get?
X plus 2 times the square root of x.
Can we all FOIL combine like terms and get that? I don't want to keep going until we all can get to this point.
6 might have to do it again.
Okay, so from here or from the beginning?
Yeah, from the 1 plus 4 to the square root of x equals. And then
Okay, so on this side of the equation, I just have a big radical, right? And when I square it, the big radical goes away.
I get that, but it's the
On this side?
yeah.
Okay, so let's go in order of the FOIL, shall we? So if I multiply the first terms together, I get 1. So I'm going to FOIL over here, right? 1 times 1 is 1. 1 times the square root of x is the square root of x. Square root of x times 1 is the square root of x. Yes? Okay, and then the square root of x times the square root of x is just x.
Okay.
And then I'm going to go ahead and combine these. I have 2 of them. So that gives me 1 plus 2 times the square root of x plus x, and then Austin just put the x for, just rearrange the order. So are we okay with that? Yeah? Okay. Now, what would you like to do next? I'll stop you if you suggest something that would make it worse.
Subtract the 1.
Okay, subtract the 1 from each side. It is gone. I like it.
Would you subtract the 2 times the square root of x from 4?
Yes, yes. Yes, let's get those radicals all on one side of the equation. So then that gives me what on the left? Mm-hmm. Mm-hmm. Well, you could. You could. Algebraically, absolutely you could. But then that's going to make you have a fraction on the right-hand side. And I know some of you really don't appreciate fractions. So could you? Yes. Is that going to give you the path of least resistance to make you more comfortable to do the rest of the problem? Probably not. You can. But at this point, I have isolated the radical expression on the left. Even though it has a coefficient of 2, it's still by itself. So what could I really do now? I could go ahead and square both sides. You have to be careful how you're addressing that coefficient, but I would at this point if you're the kind of person who wants to avoid fractions at all costs. So now I'm squaring 2 times the square root of x, multiplying it by itself, right? And then on the right-hand side, I have x squared. So if I multiply the left side, if I square that 2 times the square root of x, what am I going to get? 4x. Do you see that? 2 times 2 is 4. Square root of x times the square root of x is 4x equals x squared. Now what? Yes, get everything on one side of the equation. So we can set it equal to 0. I have x squared minus 4x equals 0. How are we factoring that? No. Greatest common factor. What is the greatest common factor? Giving me what inside the parentheses once I factor out an x? Do you see why it's not the difference of 2 squares? Yeah. If that x weren't there, yes, it would. But it is there. So a zero product property said each of these equal to 0. So I can get x equals 0, x equals 4. Are they both valid? Check it and tell me. Do we have any extraneous solutions to this problem?
How'd you get x equals 0 and x equals 4?
I set this equal to 0, and then I set this equal to 0, and I solved for x. Okay. I skipped a step. I'm sorry, Lydia. I'm sorry if that confused you. Did you get it?
Yes, I
understand. Okay.
Thank you.
And again, I would go back up here to where it's, you know, a lot could go wrong with negative radicands. So I would go back there to substitute.
Well, the square root of 0 is 1, right? All right, 0.
Anybody know the answer to that question? So the square root, as an aside, oops. The square root of 0 is really 0 to the 1/2 power, which is have we ever addressed rational exponents? With 0, no, just whole numbers, right? Do we need to check it together? Are we okay? No extraneous solutions. They're both valid. So there's my solution set. And again, with the solution set, we do, in fact, write them in numerically ascending order. There we go. That's a beautiful problem. That is a beautiful problem. All right, so tomorrow when we're online, I'm going to go over the pizza pieces. I'm going to explain how to do that problem. And then if you happen to finish that, you can attempt the pyramid functions. So that's a little bit harder, more challenging. Those will not be due. You will have a participation grade for the pizza pieces, at least tomorrow online. Then on Friday, we will do 1.6b. Okay, so you are welcome to spend the rest of class starting your homework. You should be able to make a big dent, if not complete, what you can in the homework. Now, since I kind of rearranged a few things and the homework's not due for a while, anything that you feel like we haven't done yet, since I split the 1.6a and the 1.6b and you know, did some different things with changing, adjusting the schedule. If you come across something that we haven't done before, save it because that homework's not due for a while, right? Okay, y'all are welcome to work together. I'm happy to answer any questions. Are there any questions as of right now? Homework is my math lab, yes. All right then. I will be online. I'll be here for those of you who are not in the room. I will be here. I won't leave the meeting unless you have questions, but you do not have to stay on the call. Oh, it didn't come over all the way.